The construction industry has one of the lowest ratio of women and is one of the least digitized industries. Discover now how a company has transformed its business on the construction side with AI, 5G, and IoT, and hear what it takes to succeed on this journey, both as a company and as a woman. Please welcome Alexandra Haas, Head of IoT Solutions at Swisscom.
Thank you.
You need a clicker?
Thank you. What do you think the ratio of women is in the construction industry? Probably quite low, otherwise I wouldn't ask this question.
2%? Sorry.
I would have thought so as well. Okay, it's 15%. I would have thought it's lower, but now if you think about it, if you subtract all the women in administrative functions, in HR and finance, legal, supportive functions, it's probably way lower. And then if you think about the construction industry, it's dirty work, it's very hands-on, it's with heavy tools, it's very non-digitized, very non-automated as well. To talk about construction case at a female tech conference is probably very unlikely. So before I start to talk about a construction case on a female tech conference today, let me tell you a little bit about myself. I work for Swisscom, the largest telco provider in Switzerland. I studied econometrics. For those of you who don't know what that is, it's basically a mix of math and statistics with a focus on economics. After I finished studying, I started at a consulting company, and back then, nowadays we are called data scientists. Back then, nobody really knew what to do with me, so they put me into the IT team. And luckily, back then, the topic of big data arose, and many companies were interested in that. So my focus topic became really demanded, and I ended up after a few years as the head of data and analytics. And then 2 years ago, I decided to change jobs, and I joined Swisscom as the head of IoT Solutions. IoT, it's the Internet of Things. So basically what we do is we connect things. We connect machines wirelessly instead of with cables. We are able to track and trace and monitor assets worldwide for different use cases, for tracking, I don't know, COVID vaccines, and monitor if they are cooled continuously, or other assets. We connect machines worldwide in factories, or we connect construction sites. And this is not only IoT, this is also about other buzzwords like 5G nowadays. We will talk about that today. We'll talk about AI and machine learning, image recognition. It has all the buzzwords. So I recently came back to working because I was on maternal leave, and I have a 4-month-old daughter now, and I wanted to share that just because I'm super proud and happy, and because we are at a female tech conference, I think it's good to talk about that and see that, well, right now I'm juggling both family and work, and so far it's going well. So it's my first Saturday out. It's okay. Yes. Yeah, without the kid, not out. Like I do walks. Okay, so let's deep dive into what I've brought you today is a customer of ours. And actually with this customer case, we at Swisscom, because we're not a construction company, we are a telecommunications company. But with this customer case, we won the Microsoft Global IoT Award this year. And because it's so super interesting, I want to show you a little bit what we have done and explain to you what is behind all the buzzwords I just used. So basically, the slide is super full, but it's going to be more or less the only slide I'm showing you, so I'm going to walk you through it. We did 4 use cases there, which I want to show you today. The first one, tracking and localization on a construction side. What is meant by that? This company, Romberg-Sersa, they build railway tracks worldwide. So in Switzerland, in Austria, but also somewhere in the outback of Australia. And they wanted to track and monitor their assets and machinery equipment. You would think, why monitor machinery equipment for building a construction site? If you think about a crane, it's probably not going to get lost. It's quite big. But if you then think about some deep valley in Switzerland or the vast outback of Australia, something can get lost there for once. And on the other hand, it's a simple business case, actually. A railway is built always as a straight line, more or less. And what you could do is, if you have construction sites all over the world and you want to monitor the progress of those construction sites, and you have a crane which puts down the railway tracks, and you know in the beginning of the day, the train is at location X, and at the end of the day, it's 5 kilometers further, you actually know, okay, probably they built 5 kilometers of racks that day, which is quite cool. If you know that over all your construction site, you can transparently monitor the progress and also compare the effectiveness of construction sites worldwide. So it gives you incredible insights and transparency in a huge business with more than 30,000 employees. So this is for one, why we do tracking. Then the other use case, machinery monitoring, is connected to that. So not only track the equipment, but also monitor the status. For the tracking, we actually constructed a sensor which measures the GPS location anywhere in the world. GPS is basically available anywhere in the world, so you could measure the location. But then this location has to be sent somewhere to some back end that it can be tracked locally. So the problem is now when you come to the, it's vibrating, sorry, I was just confused for 1 second. What is the challenge for a telecommunications company is that you don't have all the same technology for telecommuting data everywhere in the world. So in Switzerland, you have 3G, 4G, 5G. Since a few months, we don't have 2G anymore. So if we have a sensor which sends via 2G the data, the localization of the device, then it's not going to work in Switzerland anymore. So the challenge was to come up with a tracking device which sends over 2G in the countries which use 2G, over narrowband or Cat-M1, it's just other technologies, in other countries. So we had to create a device which was able to send via various communication technologies, the GPS location. I wanted to bring you a sensor like that today, but actually I didn't find one in our office. So I brought you something else instead for the machinery monitoring. How do we monitor machines, or why do we monitor machines? Actually, a use case which is happening quite often is that with this railway building cranes, the handbrake is pulled and they still move it because they just forget to loosen the handbrake. And as you can imagine, this is kind of unfortunate for the equipment lifetime. So if you have a gateway like this is a gateway. If you've ever seen one, there are different shapes and colors and so on, but it has an antenna. And you can plug it to basically any machine with a normal plug, Ethernet stecker, yeah, plug. So you just plug it there. Now this is really simple. It's a little bit more complicated, but it's able to read the machinery data and send it via this antenna, for example, via 3G, 4G. Now it's a broader amount of data because it's a whole machine, not just one GPS location. So we use 3G, 4G, large amounts of data, 5G, and it sends it somewhere in Switzerland to the main headquarter. So then the main headquarter knows, oh, the handbrake is pulled, but I see the GPS location moving of the train. Not good, send an alarm. This is actually automated. There's not somebody calling. But then there's other stuff like the machine is getting hotter than it should be, or you can think of all kinds of stuff, of use cases you could implement with if you connect your machines, your cranes, other building equipment with this gateway. And this is what we did, or with a similar gateway. Yeah. So this is the second use case. And then the third use case, now it's where we go into the AI part, promised you that. Image recognition on local IoT devices. What does that mean? Now, if we go back to this picture, we will not have 4G, 5G, 3G, anything G in this tunnel because it's a tunnel. So what do you do if you still want to implement some use cases in a tunnel or in the remote Australian outback where maybe there is no mobile antenna and I cannot send anything anywhere? So what I want to do is I still want to use some kind of digitization, or in this case, image recognition, to have a camera, for example, monitoring if somebody is, so if you have two railway tracks, and you are building on one, the other one is usually still in use. So you don't want people being on the in-use railway track because trains are still passing there. You cannot just stop the whole system. In Switzerland, SBB will kill you if you say, sorry, we need half a day to do this track and nobody is allowed to walk there, and you cannot just close down everything. So they just close down the track they are building on, and on the other one, nobody should be. So it's really about people's security, about their lives. So you could use cameras like the Boston Dynamics Spot. Maybe you've heard of it, and we actually used it there. And this has a camera, and you want to alarm if somebody is being or stepping on an active track, which he shouldn't be. But if you're in a tunnel and you don't have connection, you cannot send the image data to a cloud, compute and analyze the image data there with some fancy big data image recognition algorithm, and then send the alarm back. You just don't have connection. Or you need so much, the connection is so expensive, for example, in the Australian outback, to send huge amounts of imagery data to some cloud. You know what you pay when you're on holiday for streaming Netflix live on your mobile device. It's quite expensive. So the cool thing is you can analyze all the data on the device itself. So on a small camera, either the Boston Dynamics, not that small, but you can also have a small webcam, and you can basically have the cloud computing capabilities on that device. You have to pre-program it, but you can still make it learning. So the image data is analyzed on the device itself, and just the information, the end result, hey, there is somebody on the track, is sent. Then it can also be done via wireless LAN, so like a small local breakout. You don't have to have the whole mobile network, just to the workers that something is wrong. Okay, so this is what we did there. Another use case for image recognition, you see all the gravel there, the stones on the railway tracks. Huh? So when they build, they are taking out the gravel, and then they put the tracks, and then they are putting back the gravel. But they have to move the gravel away while they are building the railway tracks, because otherwise it's just in the way. And what we did, or what we're actually currently right now these days working on, is an algorithm that we have one camera looking at a pile of gravel and then computing the volume of that gravel pile, so that we know, okay, X cubic meters of gravel were extracted, and in 2 weeks they need it back. So we know how much cubic meters of gravel to return to the construction site. It's quite cool. It's not that easy, because if you just have one camera, you just have a 2D vision of the gravel pile. So if you have a pile like that, it could be symmetrical, but it could also be like really long to the back, and you wouldn't know. You just see the front. So this is where the AI comes in. We actually right now are building up a huge collection of pile imagery data, and then we can compute a probability that the pile has this and that 3D shape out of just a 2D image. You're following me more or less? Okay, it's quite cool. So this is what we do on the image recognition use case. And yeah, we are working very closely together with Microsoft there. We're using the Azure. They have a new tool called Azure Percept. For those of you like working with AI, you should check it out. It's really interesting. It's not playing with me today. Okay, so last one, network and edge cloud. Now it gets fancy, and we come to the 5G part. So you see this train here in the middle. It's actually a measurement train. So now imagine you don't want to have just a pre-programmed camera which does exactly one use case, gravel volume calculation. But you are collecting all different kinds of data on the construction side in the tunnel, imagery data, noise data, some other sensors, and you want to analyze them instantly. But you're in a tunnel, you can't. So you have some pre-programmed use cases like the gravel case, which you can implement beforehand. But then you also want to do use cases on the construction side. So what we did is we basically localized the Azure cloud. It's called Azure Stack Edge. So all the functionalities you see here are usually in the cloud, the IoT hub, event hub, SQL database, and so on. It's a cloud capability, right? Usually you connect to the internet and you can use the Azure services. Here, we put them locally. So you can have them available offline on the construction side, on this measurement train. We have kind of a local cloud with all the Azure functionalities. And then we can analyze the data there locally and also buffer the data. So if we don't have connection, right now, this train gets data from all the different devices, from the cameras and the little robot dog and so on, buffers the data, so it stores the data, and as soon as we are out of the tunnel and it has connection again, it can send the data somewhere. And this is why, you also see, we implemented a little 5G antenna on this train. So we actually have a moving 5G antenna providing connectivity for the construction site wherever they are. And as soon as this 5G antenna has connections to the rest of our mobile network or another operator's mobile network, if we're in Australia, it can send all the data and all the insights it's generated. So this is what we did. And yeah, do you have any questions?
Thank you very much, Alexandra. I can see you're very enthusiastic about your topic,
I love my job.
which is great to see. I love that. It's really nice. And you're head of IoT solutions, yes, as you mentioned. And I can imagine, as you also said, it's a quite male-dominated area you're working.
It is. I'm usually the only woman sitting in the meetings, but then sometimes Christina's with me here. She's in my team.
Nice. Yes. Some support. Yes. And is there any tip that you can give to women out there that also are trying to make their way in a male-dominated industry or sector?
Yes, definitely. There are a lot of tips, a lot of coping strategies. I mean, it can be an advantage also to be a woman because usually people remember me. Like recently, I think it was 2 weeks ago, so I was at this bigger management meeting from 2 hierarchies above me, and people came like, "Hey, Alexandra, how are you doing?" And they were all men. I was one of the only women there out of, I don't know, 40, 50 people, and I didn't recognize most of the men there, but they remembered me because I'm always the only woman. So it can be an advantage. Absolutely. It can also be quite embarrassing if they know your name and you don't even know their face. But in general, I think the best tip or suggestion I can give you, people always talk a lot about mentors. And I think it's great to have mentors for certain topics like your, I don't know, personal development or some knowledge you want to acquire. But for me, the most important thing always was to have sponsors. And there's a McKinsey workshop, I think, in parallel right now. So thank you for being here. But to give you the quintessence of that, probably I haven't heard the workshop, but sponsorship is super important. So you need to have people who sponsor you, who speak out for you, not only mentors who tell you what to do, like, oh, if you want to succeed, you should also do this course and get better at that and get better at that. At some point, I mean, you can always improve, but just accept if you are good, that you're good and you want to succeed, and find people who support you in succeeding and not only tell you.
You need someone that opens the door for you.
Yes, and who is invested in your success. So if you are successful, those people feel good about themselves because they think they helped you get there. So absolutely, try to build those relationships. Go for coffees with your boss, or don't ask them what you could improve. Ask them how you can help them, and then they become invested in you.
Great, thank you very much, Alexandra. Yeah. It was also during the break, someone mentioned this workshop about the sponsorship, and that it was the first time that they heard about sponsorship, and it's definitely very important. Thank you very much.
You're welcome.